In Unit 9, Section 4, we're going to talk about something called common logarithms and a button on your calculator that involves common logarithms, and then solving equations that require using that calculator button, the log button on either your scientific or graphing calculator. So basically what a common logarithm is, we've been talking about logs now, but a common logarithm is log base 10. Okay, so when we say common log, that means log with the base being 10. Okay, so we have a little what we call a change of base formula. That's on your reference sheet. And you can use common logs to find the log of some number in any base. And that's called the change of base. We're going to use that base 10 log and the log button on your calculator. So on your blue sheet we have this. We have the log of u in any base, and that's equal to the log of u divided by the log of the base b. Now these are understood to be base 10 logs here. And we usually don't write that 10 there, we just say the log of u divided by the log of b, and we use our calculator. So if we go over and go to the next page, let me blow this up a little bit. So we're telling you to use the change of base formula and a calculator to approximate to the nearest thousandth, and that nearest thousandth would be 3 decimal places. I'll just put 3 decimals. So this is really the u and this is the b when we're using our change of base. So really what we're thinking about, if you think about what we did earlier with logarithms, we're trying to say, okay, 20 is equal to 4 to what power? Okay, and this it comes out to be a decimal. We can't take 4 to a power, and we know it's more than 4 squared. Okay, it's not as much as 4 to the third, but the change of base formula allows us to find that decimal of what it is. And it says then to take the log of u and divide by the log of the little subscript base in base 10 and use our calculator button. So we're going to take, for this problem, we're going to take the log of 20, okay, and we're going to divide it by the log of 4 with our calculator. So if I go in and I'm using an LOG button on my calculator, that LOG button is log base 10 is what that means. All the base 10 logs for any number are programmed into the calculator. So if I go ahead and do this, I'm going to hit log of 20, and then I would suggest hitting the equals after you find the log of 20. Leave that in your calculator's display, and then divide by the log of 4. And it should be, if you do that, about 2.161 to the nearest thousandth. Okay? Now, if you go down here, you can skip number 16. That's what's called ln, the natural log, and that's actually in the next section. So anything with natural log and anything with base e, there's some in the next section you're going to be able to skip. Now we're going to go down and we're actually going to look at solving equations using this common log. So let's look at number 17 right here. If we look at 17, now if you think back to what we did earlier, okay, we tried to figure out with exponentials, what that was. Well, obviously it's going to be a decimal, okay, and you're going to be able to use the common log button on your calculator, and then we're going to round off on these to the nearest 10,000, which means 4 decimal places. So that change of base was nearest thousandth, which is 3 decimal places. This is 4. So what you're going to do is, what we did back in the earlier section was we could write both of them with the same base. Well, I can't do that with 16 and 90. I could write 16 in a smaller base, like 2 to a power, but I can't do that with 90. So what you're going to do is you're going to take the log of both sides, okay, the common log. We're going to go log of 16 to the power of n equals the log of 90. So I start off just writing log in front. Now you're going to use logarithm properties. And the one you're going to use the most is kind of that third one. When you have the log of something to the power, that goes down in front. So this really becomes n times the log of 16 equals the log of 90. Well, now how do I solve for n? I divide by log of 16, the common log of 16. I'm going to take and divide by the common log of 16. So now just like you did with the change of base formula, we have the log of 90, hit equals, and then divided by log of 16, hit equals again, and that should be approximately 1.6230 if you round off properly there.